Hello, in this video we're going to talk about the sieve of Eratosthenes. This is a great technique to find all of the prime numbers up to 100. Okay, and Eratosthenes was a great philosopher, and he's also a scientist. He's known for measuring the earth. He successfully calculated the circumference of the earth using simple geometry, relying on the angle of sunlight and distance between the two Egyptian cities, Alexandria and Syene. And he's also known as this. He also discovered or developed a highly efficient a logarithmic method used to identify all prime numbers up to any given limit. And this remains a fundamental concept in computer science and mathematics. And in mathematics, 1 is not considered a prime because a prime number is divisible by 1 and the number itself, but 1 and the number itself is still the same number, so the first prime number would be 2, okay? And 2 is divisible by 1 and 2, so those are two different factors, okay? And basically what we do is we circle the first prime number, 2, and then we cross out multiples of 2. Okay, so 4, 6, 8, 10, we got 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And we can cross out pretty much every number in these columns. Okay? So when you do multiples of 2, you are crossing out all of those digits that are multiples of 2. Okay, which is why you want to circle the first prime number. Whoops. Let me go ahead and erase that. Okay. 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100. Next, the next prime number would be 3. So we're going to circle 3, and then we cancel out all multiples of 3. So 3, 6 is already canceled, so we do 9. 12 is already canceled, so we got 15, 16, 17, 18, 21, okay, and then 24 has already been canceled out, 27, 30, 33, 36, 39, 40, 41, 42, 45, 49, 50, 48, okay, 51. So we're doing all multiples of 3, okay? 54 has been canceled out, 57, 60 has been canceled out, 63, 66 has been canceled out, so we got 69, 72 is canceled out, 75 isn't, 78 is canceled, but 81 isn't, 84 is canceled, but 87 isn't, 90 is canceled, but 93 isn't, 96 is canceled, 99 isn't, okay? The next prime number would be 5, because 5 is divisible by 1 and 5, and then you do all multiples of 5. You want to cancel out all multiples of 5. So 10, 15, 20's already been canceled out, 25 isn't, okay, 30 isn't, but 35 isn't, 40 is, 45 is, 50 is, but 55 isn't, 60 is, but 65 isn't, 70 is, but 75 already is, 80 is, 85 isn't, 90's already crossed out, 95 isn't, and 100's already crossed out. The next prime number would be 7, so we want to cancel all the numbers, all multiples of 7, so we got 7. Okay, 14 has been canceled, 21 is already canceled, 28, okay, okay, 28, 35, okay, 42, 49 isn't. Okay, so yeah, multiples of 7, so you got 7, 14, 21, 28, 35, 42, that's already been crossed out, 49 has been crossed out, 56 has been crossed out, okay, 63 has been crossed out, 70 has been crossed out, 77 hasn't, so we got to cross that out, okay. 84, yes, that's crossed out. 91, okay, 91 isn't crossed out. And then 98, that's already crossed out. Okay, so the next thing that we want to do is circle the next prime number, which would be 11. So we're going to circle 11. And then we do multiples of 11. So you got 11, and then you have 22, 33, 44, 55, 66, 77, 88, 99. That's been crossed out. The next prime number would be 13, okay? So when we do multiples of 13, okay, we start at 13, okay? And then we do 26, okay? So 26 looks like it's been crossed out, okay? And then we can do 39. Okay, 39's been crossed out, 52 has been crossed out, 65 has been crossed out, 78's been crossed out, 91's been crossed out, so we're good on that. The next prime number would be 7, okay, and then you can see 19 is another prime number, 29, 31, 37, 41, 47, okay? So we are able to get all of these prime numbers circled. 61 is another prime number. 71 is, 43 is, whoops, skipped a few, 43, 53, 59, okay. 79, 89, 73, 83, and 97. Okay, I also forgot to circle 23. So the numbers that circled in black are the prime numbers. Okay, so this is a cool little technique that you can get all the prime numbers less than 100. Okay, so, but, you're going to realize that 2, 3, 5, 7, 11, 13, 17, 19, those are the common prime numbers. So if you remember the first few, the other ones you can simply find by using this technique. It's pretty helpful. Okay, so the next thing I'd like to talk about is the divisibility rules. Okay, and the divisibility rules, the first 12 of them, if a number is divisible by 2, then the last digit has to be even. So, if the last digit ends with a, with a 0. Okay, excuse me, a 0. I can't seem to write here. 0, 2, 4, 6, 8, that sort of thing. If it ends if the last digit's an even digit, then it's going to be automatically divisible by 2. Okay, if the sum, if a number is divisible by 3, then the sum of the digits is divisible by 3, then the number is divisible by 3. Okay, so for example, if you have a number like, let's say you had 393, okay, and you want to know if that's divisible by 3, well, if you add 3 and 9, that's 12, and then 12 plus 3 is 15. If you do the sum of the digits, okay, if you do 3 plus 9 plus 3, you get 15, and then is 15 divisible by 3? We can say yes. It is divisible by 3, therefore 393 is divisible by 3. Okay, if a number is divisible by 4, then the last two digits that are must be divisible by 4. So if you have, 524, well, 24, is that divisible by 4? Because you look at the last two digits. And 24 divided by 4 is divisible by 4. 4, 8, 12, 16, 20, and 24 goes into it 6 times. Therefore, 524 is divisible by 4. If a number is divisible by 5, it must end in a 0 or a 5. Okay, if the last digit ends in a 0 or 5, then any number is divisible by 5. Like, for example, 1,255. Since the last digit ends in a 5, we know it's divisible by 5. If a number is divisible by 6, it has to be divisible by 2, which means the last digit has to end in an even digit. And then it also has to be divisible by 3, which means the sum of those digits. If that number is divisible by 3, then that number is divisible by 3. So in order for a number to be divisible by 6, it both has to be divisible by 2 and 3. So you got to check both divisibility rules for 2 and 3. And if that number is divisible by 2 and 3, then that number is divisible by 6. Okay? So in 7, the last digit, if you double the last digit and subtract it from the rest of the number, and that number is divisible by 7. Okay? If the last 3 digits are divisible by 8, then that number is divisible by 8. Okay? 9, if the sum of the digits is divisible by 9 or divisible by 9, okay? So if you add all the digits up and that new number is divisible by 9, then we can comfortably say that number is divisible by 9. Okay, 10, again, if it ends in a 0, it's automatically divisible by 10. And then there's other divisibility rules as well that you can use, but the first 10 are usually the most commonly one used, okay? This is a good little chart to use to kind of guide you to determine the divisibility rules without a calculator. Okay. The next topic we're going to talk about prime numbers and composite numbers. So prime numbers are divisible by 1 in the number itself, okay? So if you list the first few prime numbers, 1 not being prime, as I said, 1 is divisible by 1 in the number itself, but it's still the same digit, so therefore mathematicians do not place that as a prime number. So the first prime number would be 2, and then there's 3, 5, 7, 11, 13, 17, 19, 23. So all of those numbers are divisible by 1 and the number itself, okay? So here, 2 is divisible by 1 and 2. That's only 2 factors. Okay, same thing for 3, 1, and 3. 2 factors. So all of these prime numbers are divisible by only 2 factors. So therefore, those are prime numbers. A composite number, all right, now those numbers have more than 2 factors that are divisible into that number, okay? So when you think of composite numbers, it will have 2 or more factors, okay, that will divide into it. For example, 4, okay? Why is 4 a composite number? Because it's divisible by all right, it's divisible by 1, 2, and the number itself. So those are 3 factors. Okay? So yeah, another example of a composite number would be 6. Okay, so it's divisible by 1, 2, 3, and 6. So that's 4 factors. So that does not make it a prime number. Okay? So prime numbers are pretty easy to locate once you realize, oh yeah, it's only divisible by 1 in the number itself. So those numbers, once you get familiar with the first few of them, you're just going to know what they are. And all the other ones are composite. Okay? If a number is divisible by more than 2 factors, it's automatically a composite number. It'll never be prime. Okay? So another example would be 8. 8 is divisible by 1, 2, 4, and 8. Again, we have more than 2 factors, so it's not prime. Okay, thank you for watching. Hope this video was very helpful to you.